Welcome to Laser Safety Training, Laser Eyewear and Filters. This training module provides guidance on how to select appropriate eyewear or filters for your laser systems. The video will emphasize the importance of protecting your eyes against laser light, as well as making you aware of the different standards that govern the manufacture and supply of eye protectors and filters. Some of the examples used in this video are based on real-life incidents. Eyewear is always used as a last resort if other measures are not available to protect you against optical radiation. It is essential, however, that you wear them during laser alignment, as the normal engineering and administrative controls may be disabled. This underlines the need to understand the marking system. For all eyewear that complies with current regulation, you will notice that there are a series of characters printed on a label on the frame of the eyewear or etched along the top edge of the filter. Laser shields are also marked in a similar way. You need to understand what these mean so you can effectively protect yourself. The characters are laid out in the same order on all eyewear to comply with the standard EN 207, indicated by the CE mark shown here. It is illegal for laser eyewear suppliers within Europe to sell products that do not comply with either EN 207 or EN 208 standards. So do not use eyewear that does not carry the CE mark. The D, I, R and M characters relate to the type of laser that the eyewear is designed to protect against. The letter D means the eyewear protects you against continuous wave lasers. The letters I, R and M relate to protection against pulsed lasers. I provides protection against pulses lasting between 1 microsecond and 250 milliseconds, commonly known as long pulse. Other pulsed laser designations are R for giant pulsed, which are pulses lasting 1 nanosecond to 1 microsecond, and M for mode coupled, which are pulses lasting less than 1 nanosecond. In this example, the letters refer to a continuous wave beam and a giant pulse beam. Any characters after a D, I, R or M marking relate to identification of the manufacturer or the enhanced mechanical protection given by the eyewear. The codes used for mechanical strength above the basic level described in the EN 207 standard are described in the European Personal Eye Protection Standard. The range of wavelengths the eyewear should protect you from is indicated here. In this case, 1050 to 1400 nanometers. Be mindful of the fact that some lasers produce beams of various wavelengths, so ensure that the wavelength range of your eyewear is appropriate. The L rating, which indicates the eyewear's optical density, highlighted here, tells you how much the eyewear attenuates laser light. The letter B after the L shows it is compliant with the 2009 version of the BS-EN 207 standard rather than the previous version. The L rating also indicates how resistant the filters and the frames are to damage from lasers. The L rating is the reduction of the laser power progressively in factors of 10. It is important to note that eyewear is only designed to protect your eyes from an accidental direct hit from a laser beam. It is not intended to protect you during a prolonged period of exposure or direct viewing of the laser. In fact, laser eyewear is tested to withstand up to 10 seconds of exposure to continuous wave beams and 100 pulses from a pulsed laser device. Supplementary labeling can help lab users quickly select the right eyewear. There are some known issues with eyewear which we will now outline. As an extreme example, you may find some older styles of goggles restrict your field of vision. One of the most frequently used excuses for removing laser eyewear during a procedure is the discomfort felt whilst wearing it. So make sure the eyewear you use is comfortable. Goggles and eyewear can be susceptible to fogging, so ensure you are satisfied with your eyewear's ventilation. An inability to see the beam can lead to the desire to remove your eyewear momentarily. This significantly increases the risk of eye injury. The inevitable result of protecting you from certain wavelengths of light is that those colours become invisible to you. Another important factor in deciding which eyewear to use is visible light transmission, or VLT. It is important not to create a greater hazard for yourself by wearing eyewear which can't be properly seen through. The visible light transmission factor indicates how much usable light the eyewear allows through. Incidentally, this is why your laser lab should be well lit whilst you are working, except for infrequent situations such as laser alignment. As with all safety equipment, you must ensure that your eyewear is fit for purpose. They must be clean, in good condition, and free from scratches, cracks, or any other damage. Laser eyewear can be made from either plastic or glass. Eyewear made from plastic tends to be lighter than glass versions. They are usually more comfortable to wear over long periods of time and are also considerably cheaper. The disadvantage of plastic eyewear is that the filters tend to block out more visible light. Consult your laser safety officer to find out what range of laser eyewear styles are available. Whichever style of eyewear you choose, you must be satisfied that it is a snug enough fit, such that a stray beam cannot enter through gaps at the side of the frame. These wraparound styles of eyewear can improve your field of view, but you may experience some distortion around the edges of your vision. New style goggles are very effective and provide the best protection against stray beams. However, they can be uncomfortable when worn for long periods of time. The next aspect to consider when selecting your eyewear is filter type. Absorptive filters block particular wavelengths but allow others through. These can provide protection against particular laser wavelengths whilst allowing you to see sufficiently using the rest of the transmitted light. Coated filters, instead of absorbing, reflect the specified wavelengths of the laser. As a result, there is the potential for these types of filters to produce unintentional reflections. So it is important that other people in the lab are also wearing eye protection. These filters can have an angular dependence, which should be described in the manufacturer's literature. Some pulsed infrared lasers can cause particularly severe injuries if suitable eyewear isn't used with an unenclosed beam. This is a simulation of what people have reported seeing and hearing after sustaining such an injury. The injury is caused by localized boiling of the water in your eye, known as the aqueous humor, which causes a popping sound. The damaged tissue from your retina detaches, causing floaters, and blood from the damaged capillaries is released into the aqueous humor. This module has provided you with a basic overview for the use of laser eyewear and filters. We have emphasized the importance of selecting the appropriate eyewear to protect you, taking into account the way that different designs of filter are used in eyewear to protect against both continuous wave and pulsed lasers at different wavelengths. We have explained how to interpret the manufacturer labels on eyewear so their suitability for a particular laser system can be assessed. We have also highlighted the different standards that relate to eyewear manufacture, and that it is your personal responsibility to ensure that your eyes have adequate protection against optical radiation. Finally, we have given you a real demonstration of the kind of injuries that can occur if your eyes are not suitably protected. This concludes the module. For more information about laser safety, please contact your laser safety officer.